Up next is Matt Court to explain triggered source water monitoring, what that means, and what situation may cause your utility to begin source water monitoring. Matt is a registered professional geoscientist in the state of Texas with a Bachelor of Science in Geological Sciences from the University of Texas. As a member of the Public Drinking Water Protection Team, he has extensive experience in both the source water assessment and protection programs and total coliform rule programs. Matt, good morning.
Good morning, Mike. It's good to be here, and just as Mike mentioned, I wanted to talk a little bit about triggered source monitoring and also triggered source monitoring plans. All right, let's jump right in and talk about the first slide. I wanted to mention also, this has been discussed earlier, but the triggered source monitoring applies to all groundwater systems that do not provide for-log treatment of viruses and have a coliform positive in their distribution system. And that result is not invalidated. These source samples must be collected from each active well within 24 hours of notification of the initial positive. There are two exceptions for the triggered source monitoring, and one of those is invalidations. Invalidations will go through the current procedures in place by the total coliform rule. And also, the groundwater system may submit for review that a TC positive distribution sample was caused by the distribution deficiency. A couple of examples of distribution deficiencies are no chlorine residual at the site or pressure drops, which would allow infiltration of microbial contaminants into the distribution lines, or other issues that could cause a false positive. So for the triggered source monitoring, this is if a positive distribution sample would require a sample from each active well. Now the public water system, there are a lot in Texas that have many wells, and to reduce the triggered source samples, the system can provide a triggered source monitoring plan that must be approved by the TCEQ. Now, triggered source monitoring plans is covered in our 290 rules. The citation is there on the screen. Triggered source monitoring plans will describe representative wells, and there are two types of representative wells. Wells that represent other wells, and also wells that represent distribution sites in the system. Wells that are representative of each other. An example of this is well fields that contain similar wells that are in the same aquifer, have similar depths, and the construction is up to TCEQ standards. I've got some diagrams coming up that will show you some examples of these well field representative wells. Going on to the next slide, I've got some simple examples of representative wells, and you can see in the diagram here, it's got 3 wells that are all drilled into this gravel aquifer, all similar depths, so this is an excellent example of representative wells. The next slide I have shows 3 wells with one being drilled into a different aquifer. So in this case, the well in the middle here would not be representative. It's possible that these 2 wells on the ends could be representative of each other. So this is a case where not all, even though the wells are in close proximity, they may not be representative of each other. Sean Abels mentioned fractured bedrock, and this is a lot of these are in Central Texas area with the karst environment, and there's a lot of fractured limestones that even though these 2 wells are very close, they wouldn't be representative because of the inconsistencies with the geology. Going into our next slide, this is an example of 4 wells that are close in proximity, but this dark layer in the middle here is a confining layer. It's a clay layer, and you can see over on the far end here that this clay layer is very thin and would actually be an unconfined aquifer. And in this case, these 2 wells are very close together, but since the geology changes, they're not going to be representative. In this case over here, the geology correlates a lot better, and that could be an example of representative wells. And I've got some examples from our triggered source monitoring guidance document, and this is an example of a table that shows these representative relationships. In these diagrams in our document, the top table will basically describe the fields that we're looking for. The first example here is just very simple. It's got 2 wells. They're both in the same aquifer and are similar depth. So this system is designated this well A or well 1 as the representative well. And it's important to note that we like to see a backup representative well in case the primary representative well is out of service for some reason. And then going to the third example, I've got 2 well fields here, both with 4 wells each, and the system has laid it out with their well ID names and then the TCEQ source codes here. And you can see the first 4 wells are all in the same aquifer, similar depth, so they've designated this well A as their representative well. In a similar case in the lower diagram that or table that shows 4 wells in a different aquifer, but they are also representative of each other. So this is a map showing that last case. There's the well field at the top here with 4 wells. The system is designated well 1 as their representative well. And then this lower well field, well 5, has been designated. So it's real big for systems that have a lot of wells that this system has reduced their triggered source sampling requirements from 8 wells to 2. And one thing I wanted to note also, the presentation, if you have a copy of it, there is some description behind the diagrams in the presentation. And in this case, I think it may say that well 1 and well 4 are representative, but it should say well 1 and well 5. That's just a note in case you have that copy that hasn't been updated yet. But yeah, this is a good example of a map that corresponds to a table, the previous table. Moving on to the next slide, we've got a system that has 2 pressure planes, pressure zone 1, pressure zone 2, and this diagram shows well 1 contributes to the first pressure zone, and 2 wells here contribute to the second pressure zone. And these represent distribution sample sites, so it'll be important to note in your sampling plan that shows the contributing wells to each pressure zone, so you can cut down on some of the sampling that's required. Instead of sampling all 3, if you get a hit over here in pressure zone 1, you would only have to sample well 1. In this case, the well 2 and 3 represent contributing wells to this pressure zone. In this case, the system could actually designate these 2 as representative of the sample sites in this zone, but also they could also designate one of these wells being representative because they're close in proximity and have similar features as well. So that's a good example of wells that represent sample sites and wells that represent each other. So moving forward, this is a table that shows this pressure zone relationship with the sample sites. As you can see, the pressure zones are listed with the sample sites and also the wells that contribute to the zones. And this table is basically showing a similar relationship, but we want the systems to go ahead and list all their sources, even if they're not a groundwater source. Like this system has 1 surface water source, and they also have a purchase water source. So it's going to be important if the system gets a hit to notify their provider and also include their provider's PWS ID number.